Hi there, everyone. Thanks for joining this special video lecture edition of SWE 432, Web App Development. Today we're going to be covering some topics that you're probably going to find super useful as you're getting into actually doing some JavaScript coding. So we're going to talk about the different kinds of development tools that support JavaScript development and how we run JavaScript on our computers. And we're also going to talk about how we test JavaScript code. So let's start off with a little bit of a review from last time. So last class, we talked a lot about JavaScript. We talked about JavaScript object structure. And one kind of particular topic that we spent a lot of time on was considering how JavaScript lets us pass around functions like variables. So in this example code that we went through a lot last class, we see that there's this function here, full name, which is defined as a property of the object profhacker. That function we can pass around as a variable, in fact, as this variable full name. And we did that in our code example here by saying that we're going to take this new variable function and we'll assign full name to that variable. And then when we do this, we can call that function just like we would call the function normally by putting those parentheses around it. Now what was maybe kind of non-obvious from this was running this code results in the printout undefined, undefined. Whereas maybe what we were expecting was, well, this func is going to be calling profhacker.fullname. Full name is defined here, which is a function that returns first name concatenated with last name. So how the heck did we get to undefined, undefined? And the answer to that is that the definition of what, quote, this is was really tricky. When we're calling full name as a function directly on profhacker, this can refer directly to profhacker. But in the case here where we're calling it just as func, you don't see profhacker.fullname. There's nothing before func to say what this is. So then when we get up here, this was undefined. We talked about how if we wanted to get the output that we were expecting here, where actually the full name were printed out, we're going to use this magic function bind. And what bind is doing here is setting this literally to be whatever we want it to be. In this case, we're setting it to profhacker. We showed that we could even set, quote, this to be any other object that we wanted. And here we set bound this to be this other object, Ben, and then we called that function, we'd get the output with a different name. That was bind. We also talked really briefly about JSON, which was the JavaScript object notation, that open standard for transmitting data objects. You're going to be seeing this in homework 1. You're going to be seeing this throughout the class. You'll probably have seen JSON already. It's a very common interchange format. It looks just like a JavaScript object definition. We're defining our object. We've got these curly braces here. We've got our properties. We're using a colon to delineate between the name of the property and the property value. And we can nest these things also. So we've got this full name here, which is defined kind of as its own object too, which has its own properties. Main difference between defining an object in JSON and defining an object in JavaScript. Obviously in JavaScript we can have functions defined, and in JSON values are just objects or arrays, no functions. So as I mentioned today, we're going to talk about web development tools, web app development tools, stuff that we're going to use with JavaScript to make our lives a lot easier. I guess aside from just making it easier, we'll cover like how to run JavaScript code to begin with. Then we're going to talk about testing. We're going to talk about this approach to development and testing that's called behavior-driven development. We'll talk about what behavior-driven development is and why you might want to do it, especially when we're writing web apps. Beyond the maybe more theoretical part of the testing stuff, we'll talk about concretely a tool that we'll use for testing our web apps, Jest. All right, so if you're sitting at your computer now and you want to mess around with some JavaScript code, you have two high-level options for running that code. So the first is going to be running your JavaScript code in a web browser, like actually in a browser. So this is maybe the more traditional approach to executing JavaScript. JavaScript was developed for the browser, so there you go. You don't have to actually make a whole website, though, just to run a little bit of JavaScript. You can use these standard websites called paste bins that let you just really easily experiment running a little bit of JavaScript code inside of it, and then you see the result. You could also be executing your code outside of the browser, which is what we're going to focus on for now, using what we call a runtime for JavaScript. And the one that we'll use, and I guess the only one, is Node.js. You can think of Node.js as kind of like installing a JVM and then running your code in a JVM, or installing Python and running your code in Python. Node.js is handling that for us. So let's look at this idea of a paste bin first. So I've got some JavaScript code here, and I'd like to run it. So let's drop out of the presentation, and we'll go over to a browser. We opened up a paste bin. There are a lot of different paste bins that exist. JS bin is maybe the simplest for our purposes, so that's what I opened up here. Just going to go ahead and copy in this JavaScript code. I've got these tabs here showing the JavaScript section and the console. If you just go to jsbin.com, it might open up also showing some HTML thing, maybe showing the CSS thing, maybe not showing the console, but by clicking JavaScript and console, that's what we see here. We're not going to touch HTML or CSS for a little while. All right, so I got this. Let's hit run. Ta-da! It's going to print out hello world. And as I change this, I can run it again, and we're still gonna, get that to work. So this is maybe the lowest overhead way to be running JavaScript code on your computer. You installed nothing. All that you need is a running browser. But it's not obviously going to really work to support running more complicated things. So let's talk about Node.js. So Node.js is a runtime that's going to let you run JavaScript code outside of your browser. So by runtime, we mean this is a program that takes in some programs and makes them run. We'll not get into very much more specific definitions here, thinking about like interpreter or just-in-time, none of those words we're going to talk about here. Let's just say it's a runtime. So we're going to write backends, we're going to write when we're starting to actually build our web apps, the backend for it is going to be written in Node.js. That's what's going to be running on our server and handling different kinds of dynamic content. For your first homework assignment, you're going to be writing this meme generator in Node.js, nothing to do with the web stuff, just something that runs. You're going to need to download and install Node.js on your computer. There are several different versions available at any given time. There's what's called an LTS version, or long-term support version, and the most recent version. Lots of features are changing constantly in Node.js and in the JavaScript core engine that it runs on, which is Google's Chromium engine. So the newest version is always the newest, but features in it aren't really guaranteed to be super stable or for them to still exist next year, which is why we recommend the long-term support version, which is in fact designed to be stable and not have stuff changing constantly, which is really nice when you're in a class and you don't want things to be changing in your assignments while you're working on them. So it's easy to install Node.js. Of all the things that you're going to need to install, basically you'll just go to the website, and then the download link here will be correct. It will say either Mac or Windows. You can install it this way. If you're on Mac, you can also install Node.js using Homebrew. If you're on Linux, you can also install Node.js using whatever package manager you got. So I've already installed it. So here I am. I'm going to open up a terminal. And let's go into this little directory I've created for this. We'll make a new file. Just call it index.js. I'm going to copy that same code into it. And now I'm going to say node index.js. And there we go. We get that same printout. What's nice with Node is that it'll also just kind of work interactively. So if we just type node, I can put that same code in there, and there you go. We get the result too. If you do this and you've got Node open, you can get out. Typing X is not going to work. Type .exit, and you're out of there. So that's the basics of how we're going to get Node installed and how we're going to interact with it. The next thing that we need to talk about is the Node package manager. So we're going to work with libraries in this class. You're going to take other people's code that does stuff and use it. Like for instance, in the homework assignment on the term project, you're going to take someone else's library that manipulates graphics and use it to generate our memes. So how do we work with libraries? The old way of including someone else's library code in our JavaScript app was kind of messy, which was to literally define in our code a link that says include this specific file and just shove it in there. This works because it lets you include different things, but it's not great. Some things that are wrong with this are, for instance, there's no standard format to say what the name of some module or library that we're importing is. Here, I guess I'm importing this React thing, React DOM, and browser. There's no standard way to say what the version of a module is. You can see that the numbers that are indicating presumably a version are the same for the two React ones. But then for Babel, the number is showing here rather than as part of the file name. And there's no standard way to say where I find all of these things. Like if I want to find a new module, where do I go find it? This is maybe something from Facebook because it's FB. This is, I don't even know what the CDNJS thing is. How does that tell me who's making this project or where it's coming from? So what we want to be able to get to is something where we just say, hey, give me some module like React 15 and everything that I need to make it work. So this is maybe not specific at this point yet to JavaScript. This is more generic software engineering, how we can include different modules in our project. So what we want to do is have some infrastructure where we can describe all the different modules that there are. Like, here's a module for reading text input. Here's a module for manipulating graphics. We want to have some central repository of those modules so that then you as a developer can discover all of these different modules that exist. And then we want to create some utility that can automatically find and include those modules in our own development projects. So that our picture as developers should be that we're going to write some app. And our app is going to say, hey, I depend on graphics magic. And I'm going to just use it. So then we have some dependency configuration that declares exactly what modules we actually need. So for instance, in this case, maybe this is module GM. And then we have a package manager that's going to provide the modules to our application, find the code somewhere and include it. So this thing might actually know that what I need is this file gm.1.0.1.js. And it knows where to find that thing. So now all of a sudden, when we put this all together, I've got my app that just assumes that these dependencies are going to be there. I've got this configuration that says, hey, I need this GM thing. I've got this package manager that says, hey, oh, I see, you need GM. I'm going to get you this file. So now we're going to end up having all of these modules that seemingly magically appear as part of our application. In Java land, you might have seen or used dependency management systems like Gradle or Maven or Ivy. In JavaScript, there's a package manager called NPM. And a fun sidebar is that NPM is not an acronym, but it is the Node Package Manager. It does not stand for that, but we'll never spell it out again. Just when I first introduced it, it seemed important to spell it out. So the idea behind NPM is to bring some order to how we include different modules and their dependencies in our project. NPM takes a declarative approach. So in your application, you'll say, I've got an application and it is called Hello World. It is currently version 1. You can run my application by saying nodeindex.js. I need a module called Express. I don't really care what version it is, just make sure I have the most recent version of Express. This configuration is then stored in a JSON format, and it's specifically a file called package.json. So this might be the declarative configuration that describes this project in code. It's got a name, Hello World. It's got a version 1.0. I didn't give it a description. I gave it this main thing that's index.js. I haven't yet described how I should test it. So now if I tell NPM to test it, it's going to just literally print out error, no test specified, and then exit. We'll change that later once we get to actually doing testing. I didn't specify an author, I didn't specify a license, and here I've got this dependency that I want. How do we tell NPM that we would like to install a package? Well, we're going to use this command line or tool, npm. To install something, we say install. We specify the name of the package, and then this is kind of important using this -- save. So just the npm install part is going to download the package, but then by saying save, it's also going to add to that package.json file, hey, in the future, if someone else tries to install this thing, also give them this package. If we just type npm install without specifying the package, it's going to go through all of the packages in that package.json file, which are the ones that we've defined previously, and just make sure that they're installed or up to date. When it does that, all of the packages are going to go into this special node modules directory in our project. Using npm. So your project to npm is just simply a directory that has this special file called package.json. Everything that's going to be in your project goes in this directory. So to use npm, first off, you can create a starter project that's going to have just that bare bones template that says the name of the project, the version, some default stuff. You can do that by typing npm init. Then you'll declare dependencies using npm install and then the package name. And again, noting, maybe we should add this to the slide, that you'll probably want to say -- save, which will add those dependencies to the package.json too. To use those modules in our app, we're going to just use this require keyword, saying I'd like to require that this package is there, and this is how I'll reference it. Brief note, if you're using Git for your JavaScript project, for your NPM project, you really don't want to include this node modules folder in your repository. A few reasons for that. First off, it might be really big. It might end up being like 30 to 60 megabytes just because of all the stuff that you required. And secondly, because there might be platform-specific stuff in there that's specific to your computer, aside from differences between Mac or Windows. Just there's no reason for you to save the node modules folder when you put something in version control, so we'll just use always npm install when we're on a new computer and we check out a project. That'll do that. Let's do a quick dry run of this in our sample project here. So I'm going to do npm init. Now it's going to ask us a whole bunch of questions. You can probably just accept the defaults for all of them until we get to the point where we want to share something. And now you see all that this did was create this package.json file. And inside of it, again, just like on the slide, this default thing. Note that it wasn't necessary for me to make that package.json file just to do this, to do node index.js. It's going to become necessary to have node set up, to have npm set up though, once we start using modules. npm scripts. So, wow, that's really bad. npm scripts. So scripts are just simply definitions for npm of stuff that it should do at certain times. For starters, we're just going to worry about test scripts, but this can get really complicated where you say, hey, define this script start, and to do that, do this, describe the script build, and to do that, do this, describe the script dev, and wow, there's like a whole bunch of stuff here. Hopefully none of our projects get this complicated. We'll revisit the test script when we get there. All right, so let's look at an example of using npm a little bit more complicated now. While we're at it, I'm also going to demo getting this all into an IDE. I'm happy using a text editor, happy using IDE, especially for stuff where I want to debug though, an IDE is really nice. So I've got that directory on my computer now. I'm in IntelliJ that I've set up with all the JavaScript stuff. If you don't have this installed, I'd recommend just installing WebStorm, which again will be free with your educational license. I'm going to open up that folder. New one. Close the other ones. And here's that file. So again, we're not actually really taking advantage of anything that npm has to offer yet because we're not using any modules. But just to show running things in IDE, I could hit run in here too. Oops, I don't want to run example. I want to run index.js. We can do this all directly in the IDE without having to drop out and go to the terminal. We can also set a breakpoint just like we would in Java. I can hit debug. And boom, look how cool that is. I get all of the same kind of inspection stuff that you would hope in any other language. And because it's IntelliJ, it does a nice thing where in the code, you see it's overlaying the variable names. It's very cool. That runs. Let's use a package though. All right, so let's go ahead then and try to install a super simple package. So I'm going to do npm install --save, and we're going to install a package called hello-world-npm. This is, as you might guess from the name, a Hello World package. So now that I did that install, we can see that our package.json does have a dependency specified, and it's hello world npm. If you're curious of this hat 1.1.1, this is saying it should be a version of at least 1.1.1, which is what the version is right when I typed this. So don't go backwards, but it can go forwards. Now I can also take a look at the node modules folder, and you see that this hello world npm thing was installed. I can go back into my simple file here. Let's get rid of this old hello SWE 432, and we'll usher in the new npm-based hello world. So let's say hello equals require hello world npm, which was the name of that module we included. And hello world npm exposes just a single function as this, so I can now say just hello, run it. Oh. Maybe we'll try console.log hello. Yep, and there you go. You see it's printing out hello world npm, which is what is defined in this other package. Again, just for completeness, you can see I can run on the command line too, and I'm getting hello world npm. This is obviously a very simple module. It's probably going to be much more useful to use more complicated modules like we'll see again in homework 1. There we are. So we'll come back and do some more code demos and walkthroughs. Once we get through the testing material, we'll look at writing some tests. Let's talk about tests first, though. So there are two high-level kinds of tests that we might consider: unit and integration tests. This is hopefully just a little bit of a refresher, stuff that you've seen in 321 or elsewhere. So unit testing is how we test just some small program unit in isolation from the rest of the system. Unit testing is nice because the whole system might not exist yet, and we can check just one little part of it. Usually the programmer is responsible for testing these units during its implementation, even though this might violate some rule about a programmer not testing their own software. Who knows? This is kind of I don't know that I would cross out these days, but let's maybe put yellow through this. Maybe it's good for us to test our own software. Maybe it's not good. We're not really sure about that. That's some software engineering research. The good news about unit testing is that why we do this, usually it's easier to debug when a test finds a bug compared to doing maybe some full system testing where we're checking a lot of things. So unit testing is just going to test some small focused area in comparison to integration testing. The idea with integration testing is that maybe we have some units that worked in isolation, but they might not work in combination. So I put a bunch of stuff together. Each one of those components works fine, but putting it all together, maybe they don't work together. We usually do our integration testing after all of the units have passed their unit tests. We might reuse unit test cases that are crossing different unit boundaries. We'll talk about stubs and drivers later. Obligatory last word, comparing unit and integration testing. This might be considered unit testing the lock to make sure that the lock works, but then integration testing reveals that even though the lock works on its own, it was in fact a sliding door that we're trying to lock, and hence it doesn't really make much sense. So we're going to be writing primarily unit tests are what I'm going to ask you to write in homework 1. We'll take a look at that at the end of the lecture, though, and see how there are already some integration tests that I provided for you. Oops. So we would like to write good tests. That's something that we strive to do when we write tests, because what's the point if we're not writing good ones? So kind of perpetual question in testing, for testing anything, be it JavaScript or Java or C or Ruby or Python, is how we know that we've tested enough. Some questions that we might ask are, did we test all of the features that we created? And for all of those features that we created, did we test all possible values for those features to see that they represent everything that could happen in reality? So an approach to answering these questions is to structure your tests in such a way that just from looking at the tests, it should be clear how we did. Something that's become incredibly popular in testing, specifically in testing JavaScript code, but increasingly so with other kind of testing, is called behavior-driven development. So with behavior-driven development, we establish specifications that say what an app should do. And we want to write these specifications before we write any code. All the code that we write should exist just to take those specifications and make them work. We provide some mapping between the specs and then something that an end user can actually observe as the application functioning. Really, the key idea is that we want to have some clear map from the spec to the tests. And we'll use a real-world example to make this a lot more concrete in terms of specs and tests. So let's imagine that we're implementing an investment app. This investment tracker app is going to allow users to make investments by entering some stock ticker symbol, like PETO. The number of shares that we want to have, and the price that maybe we paid for those shares. When we click Add, this is going to add that stock to the investment tracker. So here maybe we already did this and it's added. And the user is now going to see the current status of all of their investments. So in this case, we can see that this investment is good. It's green. It has returned 101.80% compared to the price that was paid, comparing to the price today. And this other investment maybe did very poorly because you can see that it's down, it's red is bad, and this number here, negative 42.34%, means that the return on the investment is negative. So what we want to do is test this thing. We want to write some specifications and then turn those into tests. So the question to start with is, what's an investment for our app? So we could give a spec like, given an investment, and an investment should be an investment of a stock, and that stock should exist. The investment should have, representing part of it is the number of shares that we have purchased, as well as the price that we paid for that. And an investment should also have something that represents what the current price of the stock that it is of is. Lastly, when its current price is higher than the paid price, the investment should have a positive return on an investment. So I guess that means we're probably going to show it as green. And it should be a good investment. So if we want to take this kind of specification and convert it into actual tests, we can use a framework like Jest. Jest is a pretty popular JavaScript testing framework. Jest comes out of Facebook, who also developed React, which is a front-end framework that we're going to be using later on in the class. So Jest is going to integrate really nicely with all of this. Testing, especially JavaScript testing, is not necessarily the most fun thing, which is why you can tell the Facebook folks really are trying here to make it as useful and delightful, they would say, as they could. So we'll cut into an example and install Jest in a little bit, but let's just stay at a high level and stay in the slides for a few more minutes. So with Jest, we specify our behavior in terms of specs. These specs are just simply JavaScript code. There are three key functions that we're going to use, which are describe, test, and expect. So when we use jest, these are just going to be magic functions that exist, that get imported. The idea is that we describe some high-level scenario by providing a name for the scenario. And then we're going to give that scenario some functions that are going to have these tests, that are going to say exactly what we expect to happen. So as an example, dropping out of the investment world and into maybe something a little bit simpler, the code snippet that we were going through at the beginning of lecture and also last week, where we were looking at the bind stuff. We could give a spec that describes how function calling works on our professor object. So here I say that I'm describing Alyssa P. Hacker's tests. Maybe we could call this something more inventive, but given this is kind of a contrived example here, it's hard to say what else we would put here. Then one test might be that calling full name directly, so directly on Prof. Hacker, should always work. It should always return the right thing. So I say that in this test, I will expect that the return value of this thing, calling profhacker.fullname, should equal, and then that's what we think it should equal. We can also specify some code that's going to run before or after checking a spec. So in this case, we might define as some sort of global for our test the prof hacker variable, and then tell jest that before each test runs, we'd like it to run this function here. Remember again that this is just syntactic sugar here for saying function. Just kind of a shorter way of saying that. And we've defined then that before each test runs, we'd like it to reinitialize this prof hacker variable. How do we make it work? Well, we need to add jest to our project. We'll run that from the command line. We'll use the npm install. Rather than save, we're going to say -- save dev, though. The dev part means don't use this thing when we're actually deploying our project. I only need this module when I'm developing it, which will be the case for jest. Then we're going to configure npm and tell it that jest is how we want to run our tests. So we'll change our package.json file so that where it says scripts test, the default here was that test was going to print out, oh, you didn't specify how to run tests. So instead, we'll just say test, use jest. The common naming convention for where we put our tests in JavaScript, especially for a small project that doesn't have millions of these things, for every file x.js, we'll just make another one, x.test.js. Then to get these things to run, we'll just run npm test. So let's drop back to that npm example and do this. So I'm going to do npm install -- save dev jest. It's going to take a few minutes. You can tell that the Hello World project was very small, probably in terms of megabytes and dependencies and all that stuff. Compared to jest, jest requires a lot of things. You'll notice that it said added 634 packages from 363 contributors just to get us this one jest thing. So npm is handling the fact that jest itself requires a whole bunch of other stuff. So when we say, hey, I would like jest, now if you look in node modules, wow, there's a whole ton of stuff. That's stuff that jest uses. All right, let's jump back into IntelliJ. Let's open our package.json file. And we're going to change, as we said, the script for test to be use jest. I'm going to make a new file. Why is this scratch? Sorry. Oh, let's make it over here. I made my new file, index.test.js. Maybe we'll put some of that code in here that we had before. So I put in this before each. And we can just put in one of these tests. Now I can say npm test. And we see a pass. There's only one test here. One passed, one total. Yeah, so we can also go ahead and run this test just one-off directly in my IDE. I hit the run command and selected that one test. And we see that it ran just that one. So if we want to go crazy here and have more tests, maybe we could have one like test calling full name without binding, but with a function. Now we might do something a little bit more complicated. I can say func is profhacker.fullname, and we're going to expect that calling just func without doing anything is going to equal and I can again choose just to run this one, and we see that work too. We said that if we wanted to group tests together, we could use that describe. We won't say stupid. And now this is going to be kind of the same thing. I can run tests individually here, or I can be running them here. And now you'll notice that the output is going to nest those tests under this. It's really just for convenience that when we read this in the output, we can really map back from this stuff to what our specifications are. In terms of this before stuff, so why do I care about doing this before each? Well, we might write another test that changes this. Like, let's say test changing name changes the full name. And in this case, let's change profhacker.fullname or first name. So now in this one test, we're going to expect that the full name is going to be different, but in this one, we're expecting it's going to be Alyssa P. Hacker, and it shouldn't matter what order these things run in. We want to make sure that that prof hacker thing got reset, which is why we put that prof hacker initialization in the before each. So that's going to run before each test. Cool, everything is still passing. Again, if I wanted to debug something here, this can be really nice using my debugger. I'm going to hit the key command to open up debug. I say, yes, I'd like to debug this one test. Put my breakpoint there. And you can see what func is, which is, I guess, really the only thing that we're referencing here. This is just, compared to using system.out or console.log rather for doing debugging, this is a lot nicer. So look at this, very cool, right? I would really strongly recommend getting used to and comfortable using an IDE for debugging. Okay. So again, we can have as many tests as we would like. We just keep layering them all into the file there. I could define a whole bunch. We can nest the specs, like I showed in the example. Maybe going back to the idea of the investment, we could describe a scenario like when the stock's current price is higher than the paid price, we have a few things that we want to test in that scenario. So we have this nesting between the describe and the test, which goes back up against literally what our spec was, where we had this thing and then this stuff nested within it. Maybe last thing with jest, conceptually that we want to talk about are the matchers. So that's this part here, where here it said to be truthy, and here we said to be greater than. So when we tell jest that we want it to expect something, we can use what are called matchers, which are going to compare some given value back up against some criteria. So the basic matchers that are built into jest are to be, to equal, to be truthy, to be not a number, to be null, to be undefined, and then all of your normal stuff like greater than, less than, or equal to. These are all in the jest documentation. Again, you can see kind of these examples here. You can also define your own matcher if you want to. I think that these are mostly self-explanatory. NaN, not a number, undefined, undefined. Truthy is kind of the weird one. So truthiness is really just this JavaScript notion of if you were to say if blank, the question is, does this code run? Is this condition truthy? Truthy we use instead of the word true because things that are not necessarily just true are truthy. So literally the word, the keyword true, yes, that is truthy. Any number that's not 0 is also truthy. Any string that is not empty is also truthy. And also any array or object is also truthy. Things that are not truthy are false, 0, an empty string, undefined. Yes. All right. So before we get into maybe a little bit more discussion of the first assignment, I'd like to introduce the notion of a promise, just because this is something that is going to come up immediately if you want to start working on the assignment right now. Promises are wrappers around asynchronous callbacks. And we're going to put off talking about the asynchronous part until the next lecture, but we can talk about promises without really understanding what the asynchronous thing is. A promise is a special object that represents how to get a value. So rather than necessarily returning a value, we might have some cases in our code where it's better to not return the actual value, but to return some sort of pointer that says, if you really want this thing, this is how you get it. So then when the developer who's using the promise needs to do something, they can say to the promise, hey, promise, if you ever get around to getting that value, then do this thing. So promises are really useful because they organize many different steps that might need to happen in a specific order. So given some abstract promise, promises are either going to be successful, failed, or not yet known because they haven't gotten their value yet. So again, we start abstract. It's going to get clearer as we get more concrete. How do we use promises? So assuming that someone else has written some promise, how does our code work? So here we might have some function that returns a promise called fetch. So this thing returns promise. So fetch is going to get some data from, say, in this case, github.com, because that's what we've specified here. And rather than necessarily returning the data right away, fetch is going to know how to get that data and it might get it eventually. So now again, we're this code that's trying to fetch stuff. So we know that this fetch thing returns a promise. So we have a promise here. So we use this then function, which is standard defined for every promise, and then accepts a function. So this function here is going to be called when the promise is completed, when it goes off and does whatever it's supposed to do and gets back with its data. And this one argument that it takes is going to be whatever data the promise completes with. So what this code on top here is going to do is request this promise to go off and fetch this data from github.com and then say, hey, whenever this thing completes, then do something, return back this text. Promises are kind of a high-level way to handle errors also. So in addition to saying then, which will happen when the promise is successful, we can specify a catch function. And instead of getting the result here, it's going to get passed an error. So if we request some promise that doesn't succeed, in this case, it probably won't, we're going to handle that in this simple error handler. So one thing that's nice about using promises is that you can promise one thing and then another. So you might request a promise to get some data and say that then you should promise to get some other data based on that data, and then use that data to update some state in your application. And say for all of these things, if there's an error, just go report on it. So again, this is going to get really powerful when these things are happening in parallel in the background in all different orders and craziness. But for the sake of getting started with the assignment, just assume that these promises happen one after another always. Nothing happens while they're happening. So if we want to chain these things, you can say take this promise and then go off and do something, and then go off and do something else, and then go off and do something else, and so on and so forth, and then catch all of the errors. This would be the JavaScript code version of the diagram on the last slide. We can also request that a whole bunch of promises happen, and then something else happens. So in this case, we use this promise.all syntax. I'm going to pass it an array of promises. So again, these brackets are saying make an array, and then the array is going to be full of these promises. Load image, I guess, returns a promise. And then once all of those results come in, we're going to have this function here that we want to get called. Because I have an array of promises, I get an array of results. And then I can do stuff with all of those results. Maybe I'll do some for each stuff. Who knows with document.body? Maybe let's ignore that part. And then say, again, niceness with the promise API, we're just going to catch all of the errors in one place. From any of those promises, the result comes there. How we write a promise. You're going to need to write a promise pretty quickly for the first homework assignment. Most often, when we're interacting with promises, they're being generated by some API function, like this fetch thing that might go off and get some data. But you can also create your own promise, and again, you will. Writing a promise is super simple. So I have this code example here. That's all that you need. To define a promise takes a function, and that function takes two arguments. Both of these arguments are going to be two other functions. The first one is called resolve, and the second one is called reject. Your promise is just going to have some code in it that does stuff. It's going to do whatever it needs to do. Does stuff. And then at some point in your promise, it might have some condition that says that this is okay. Condition is okay. And in that case, if the condition is okay, we call the resolve function. And that pass it some value, which we want to return back and say that was the thing that we were trying to get and we got it. If the promise is not successful, then we call reject. We're going to give it some error. We might pass an exception, or we might just pass a string. In the case of the first homework assignment, we're just going to pass a string and keep it simple. So here's an example of this load image promise that I referred to on a prior slide. Load image is going to return a promise to load in some image. So inside of the promise declaration function here, I'm going to do my work. My work is going to be create this new image object, specify its source, specify this onload thing, and when onload happens, I'm going to call resolve, and if onError happens, I'm going to call reject. Once the image is loaded, that's going to cause this thing to happen. It'll get resolved. If there's some error in here, we'll call this reject. Again, we don't need to worry about what images or how it works. All that we care about here is we're writing this promise body that does stuff. In some cases, we're going to call resolve, and in other cases, we're going to call reject. That's really all that the promise has to it. Okay, so I hope that this now should be enough to get you started on homework 1 at least. Let's just take a few minutes, and I'd really like to show off a little bit of the starter code that we've got. All right, so I hope that by now everyone has had a chance to at least skim over the assignment write-up for homework 1. You do have the handout that's ready to go. I am going to take a look at this maybe instead of from the assignment side, from the code side. This is the handout in IntelliJ, and I'd like to just kind of make clear all the stuff that is stubbed out for you. So starting off, I've given you this really simple index.js file that's a driver for the meme generator. So the meme generator has a few methods that you're going to implement. The driver takes in a list of sample meme templates and a list of sample meme configurations and generates all of them. So based on what we were just talking about with promises, you can see kind of exactly that same syntax here. So just walking through exactly what this code does. We're going to load in this test file from samplememes.json. This is a list of meme configurations. So we load tests in, and then for each of the memes, we're going to push into a list of promises the result of calling generator.generateMeme, because again, this thing is going to return a promise. After we make that list of all the promises, we're going to use that promise API to promise that all of those things happen, and then just print out done. And if there's an error, we're going to print out error. So again, why am I crazy with the debugger? Let's find out. I'll throw a breakpoint right there. Let's hit debug. Why is this test.memes and not just tests? Well, it's pretty easy if you hit the debug that you can see, well, what's tests? Test is an object. That object starts with memes. Memes is an array. Okay, and then each one of these memes is this thing. So that's why I'm not saying test.forEach. I'm saying test.memes.forEach, and then I know that memes is an array, so I can use for each, so on and so forth. Just again, if you're messing around with stuff, maybe using the debugger can be easy. If we were to run this right away, I guess that we get nothing, because that's what's happening by default. What's happening by default in generate meme? Generate meme is just going to return this new promise that does nothing. You're going to need to do stuff here. maybe just, again, as a sample, we're messing around with promises. Let's make this thing just always call resolve. Actually, that's probably a bad idea. Let's make it always call reject, because it's not going to do anything. And we'll reject with a message that says error not implemented. Now if I run it again, ta-da, printing out our message that error is not implemented. In here, you're going to want to do exactly what the spec says, right? So you'll want to validate the meme. If it doesn't validate, you're going to reject it. Otherwise, you're going to try to resolve it. That's cool. That's that. Let's take a look at the tests. So you're going to be extending these tests. In your handout here, you've got these specs for these 4 tests here that are blank. Invalid meme name generates exception, meme with invalid text generates exception, meme with invalid text, blah, blah. Missing meme image generates an exception. So what you're going to need to be doing in these tests is maybe try to create a meme with whatever config is specified by test, and then you're going to expect maybe that the exception is exactly what is specified in the spec. You'll want to expect here, like literally expect, like using the term from jest, expect that the exception matches what we need. Just for those who are curious, you can see that there's a bunch of other stuff here too. We're using a whole bunch of modules. We're using FS, we're using PNG, we're using pixel match. You'll probably need to use at least FS and GM. Oh, I already did that for you here. Very nice. You'll use FS and GM in implementing your meme generator. The tests are also doing somewhat more complicated stuff. So I mentioned that there's some integration tests that I provided. So for each of those sample memes, I have provided this integration test that says, oops, I don't know why that keeps happening. I said, try to generate this meme. I'm going to make my meme generator. When we talk more about asynchronous stuff, we'll understand why this expect.assertions too, but we'll get there next class. And then I want to try to generate a meme using this meme configuration. And again, this is returning a promise. So then once it generates the meme, I'm going to read in the meme that was generated. I'm also going to read in the reference image. Hopefully this won't become a huge problem, but there are slight differences between Mac and Windows in terms of the reference image. If you look between the two of them, the way that the font gets laid out is like really slightly different. But there's a slight difference. I'm going to expect that the width of the images matches. So expect can take an object and then compare that against another object too. So I made an object that has width and height. I'm comparing that against another object with width and height, testing between the image that you generate from your code and my reference image. I'm going to make this difference graphic, which might get used or might not. We're using this pixel match library. So again, this is like why it's so cool to be able to pick up other people's JavaScript libraries and use them. So if we look at the documentation for this, this is supposedly the smallest, simplest, and fastest JavaScript pixel level image comparison library. This is used to compare images and tests, which is exactly what we're doing. So what this does is it takes as input an expected and an actual image, and then it produces a difference showing what's wrong. Cool, so we're using that too. We expect that there should be no difference in the images, so I expect that the difference in pixels should be 0. If it's not 0, I'm going to take this difference buffer and we'll save it so that you can open it and see what's different. And we did that for each one of those sample memes. You can just kind of see that it may be as a reference for the test. In terms of resources that you should be looking at here, well, we've linked in the in the homework assignment, graphics magic. Here, graphics magic. You can also maybe find the documentation for jest. There's some description about using matchers, all of this stuff about doing asynchronous stuff. Hopefully we can put off talking about asynchronous until next time, but we understand that we're using this promise thing, so that's how they tell you to use promises. We did that in here too. So I think that pretty much concludes it for this lecture. If you have any questions, please post on Piazza. The TA, Mia, will have her office hours on Tuesday, but again, I am out of town this week. So good luck. I hope you enjoy your week. Bye.